In an exponential function, we say when an unknown is the index or power, like the one we just solved, x was the unknown as the index. But this time they say either index or power of a function, that is a number, then it is an exponential function. Example, 3 raised to the power x is equals to 9. 3 raised to the power x is equals to 9. The x is unknown. That is an exponential word function. So this can easily be saying 3 raised to the power x is equals to 3 raised to the power 2, because this will give us 9. This will cancel this because they are the same. X is equals to 2 in this case. So that is what we talk about exponential function. So the unknown can also be at the base. Such equation can only be solved if both sides can be expressed in the same base. So I have to express this, the both sides can be expressed in the same base. That is the only time I can solve it. If I can't express them to the same base, then I can't solve it. So in an exponential function, there will always be an unknown which you are looking for, x, y, z, whatever it is. But the the factor is, if you can bring the both sides to have the same base or the same index, good. Then you can get to your answer. Let's take another question. 2 raised to the power x is equals to 16. 2 raised to the power x is equals to 16. 2 raised to the power x is there. This is equals to 16 is 2 raised to the power 4. So the 2 can cancel. X is equals to 4. So that is exponential function. We'll take more of this. Next question. Simplify x raised to the power 1 over 3. Simplify x raised to the power 1 over 3 is equals to x, what is it? Is equals to 3. Now, this change of subject or formula has taught us some basic principles which we use to solve things like this. This is indices, don't forget that. But there are other topics that can always come across it. So mathematics is a unified course or subject that its knowledge is vastly used almost in everything you do. So even in one topic or the other, you continue to see various other topics reflecting. So in change of subject, they've told us that when an unknown, let's say a, is raised to the power of 2, for you to make a to stand out alone as a subject, you root both sides. You multiply both sides, or you root it both sides by that's in the square root, square root, both sides, and that take care of it. For example, if I have a raised to the power 2, I want to remove 2. I have to multiply it with 1 over 2, and 1 over 2 is square root. So that 2 times 1 is 2, divided by 2 is 1. A raised to the power 1, a is alone. The same thing applies when I have a raised to the power 1 over 2. For me to remove this, I will have to square it. The same law. So if this, I could root it to get rid of this, and in this other case, I can also square it to get rid of it. If you come here, this is 1 over 3, which is cube root, which means the only way to remove the cube root is to cube both sides, raise it to the power of 3. By so doing, you can take care of that. So let's see how that works. So for me to get rid of that, I have to raise it with the power of 3. Multiply through. Yeah, not multiply through. Raise it to the power of 3. So this is x raised to the power 1 over 3. Raised to the power 3 is equals to 3 raised to the power 3. So this is x raised to the power 1 times 3 is 3, divided by 3 is 1. Or let's put it 3 over 3 is equals to 3 divided by raised to the power 3 is 27. This cancel this is 1. So x raised to the power 1 is x is equals to 27. So we go. Let's see more. 27 raised to the power x plus 2 27 raised to the power x plus 2 is equals to 9 raised to the power of 2x. 9 raised to the power 2x. Okay. Now, what is common between these two is that I can reduce this to have a base of 3, and this I can also do the same. So here is 3 raised to the power of 3 will give me 27, all raised to the power of x plus 2 is equals to 3 raised to the power 2 here, all raised to the power 2x. Power's law of indices. When a number 3 is raised to a certain power 3, which is again raised to another power x plus 2, that this number 3 is said to be in powers, that the powers are multiplied together for final result. So I now have 3 raised to the power of 3 times x plus 2. That is what it means. It's equals to 3 raised to the power 2 times 2x. I will expand this fraction with talk about bracket. You resolve brackets for anything. So this is 3 raised to the power 3 times x is 3x plus 3 times 2 is 6. Is equals to 3 raised to the power 2 times 2x is 4x. Now I have the same base. I cancel. I have 3x plus 6 is equals to 4x. Now, collection of like things. We are now in linear algebra, another topic in mathematics. So in linear algebra, we collect like things, right? So let's see, I now have 3x minus 4x is equals to minus 6. Collecting like things, this is my 3x, this is 4x, crosses over to this side. It was positive, becomes negative. I have minus 4x. And this is plus 6, cross over to the other side, becomes minus 6. So we'll collect like and bring the variables that are like one side. Now 3x minus 4x is minus x. This is equal to minus 6. We divide both sides by minus sign to get rid of this, and I have x is equals to 6. Okay, let's take another question. 8 raised to the power x minus 3. 8 raised to the power x minus 3 minus 3, okay, x minus 3 is equals to 32 raised to the power x plus 2 over 4 raised to the power minus x, 4 raised to the power minus x. Let me certify. 8 raised to the power x minus 3 is equals to 32 raised to the power x plus 2 over 4 raised to the power minus x. Okay. Yeah. The good thing about them all is that they all have something in common. 2 is here, 2 is here, 2 is here. First thing to start with. So I want to start 2. I have here becomes 2 raised to the power 3, open bracket, x minus 3. Is equals to, here is 2 raised to the power 5, open bracket, x plus 2 over 2 raised to the power 2, open bracket, minus x. 2 raised to the power 3 times x is 3x minus 3 times 3 is 9. Is equals to 2 raised to the power 5 times x is 5x plus 5 times 2 is 10 over 2 raised to the power 2 times minus 2 x is minus 2x. Okay, let's cross multiply. Let me have them on the same platform. This is over 1. So by cross multiplication, this times this and this times this. So I have my 2 raised to the power 3x minus 9 times 2 raised to the power minus 2x is equals to 2 raised to the power 5x plus 10 times 1 is the same. Okay. Now, it says that when number with equal bases are multiplied, their powers are added. Let's add the powers. So this is 2 raised to the power 3x minus 9 plus minus 2x is equals to 2 raised to the power 5x plus 10. Okay, this is plus, so let me write it well. Plus. So this is 2 raised to the power 3x minus 9 plus times minus is minus 2x is equals to 2 raised to the power 5x plus 10. Now, the bases are the same. I cancel out. So this will cancel this. I have now 3x minus 9 minus 2x is equals to 5x plus 10. Collect like terms. Collect like terms. This is 3x minus 2x minus 5x is equals to 10 plus 9. Okay. 3x minus 2x minus 5x is minus 7x. So 3x minus 7x is equals to 19. Okay, 3x minus 7x is minus 4x. Minus 4x is equals to 19. Divide both sides by minus 4, minus 4. This will cancel this. X is equals to minus 4, 4, 4, 2, 8, 4, 3, 12, 4, 4, 16. 4, 4. 16, 17, 18, 19. Remember 3 over 4. Let's take another question. Solve for x in the equations. So let's take like 5, 6 more questions. We need to, this is the thing about mathematics. The more questions you solve, you begin to see the different angles in which one question can be resolved. Or probably maybe you've been taught of 1 or 2 questions, so you've seen those examples. But by the time you see like 5, 6, 7 examples related to that same thing, you have a broader understanding of what you're dealing with. Okay, your scope will be widened. So let's take another question. Okay, we'll call it number 4. Let's take 2x equals to 64. 2 raised to the power x is equals to 64. Okay, this seems more simplified compared to the last one we just saw. So I bring that to the same base. So this is 2 raised to the power x is equals to 2 raised to the power 6. 5 is 32 times 2, 64. So they are the same. I cancel my x is equals to 6. That's question 4. Question 5. 5 raised to the power x plus 1. X plus 1 is equals to 625. 625. So I have 5 raised to the power x plus 1 is equal to 5 raised to the power of 4. This will cancel this. I have x plus 1 is equal to 4. Collection of like terms, x is equal to 4 minus 1, x is equal to 3. That's my fifth question. Let's take some more. The sixth question. 4 raised to the power x plus 1. 4 raised to the power x plus 1 is equal to 8 raised to the power x plus 2. Bring them to the same base. This becomes 2 raised to the power 2 x plus 1 is equal to 2 raised to the power 3 x plus 2. Powers law, you multiply. This is 2 raised to the power 2 times x is 2x. 2 times 1 is 2. Is equal to 2 raised to the power 3 times x is 3x. Plus 3 times 2 is 6. I can cancel this. I have 2x plus 2 is equal to 3x plus 6. I collect like terms. 2x minus 3x is equal to 6 minus 2. This is minus x is equal to 4. Divide both sides by minus. X is equal to 4 minus. 2 minus 3 is minus x. 2x minus 3x minus x. So that's our sixth question. Let's go to the seventh. If 3 times 9, number 7. If 3 times 9 raised to the power 1 plus x is equal to 27 raised to the power minus x. 27 raised to the power minus x. So they say, if 3 times 9 raised to the power 1 plus x is equal to 27 raised to the power minus x, find x. Alright. If 3 times 9 raised to the power 1 plus x is equal to 27 raised to the power minus x, we should find x. Okay. Now all these numbers, I can have a common base, which is 3. So I have my 3 times 3 raised to the power 2, 1 plus x is equal to 3 raised to the power 3 minus x. Now this is raised to the power 1. So I have 3 raised to the power 1 times 3 raised to the power 2 times 1 is 2 plus 2 times x is 2x. This is equal to 3 raised to the power 3 times minus x is minus 3x. Now, multiplication law says that when numbers with equal bases are multiplied, the powers are added. So I now have 3 raised to the power 1 plus 2 plus 2x is equal to 3 raised to the power minus 3x. Now I take this out, they have the same base. 1 plus 2 is 3 plus 2x is equal to minus 3x. Collection of like terms. Okay, let's come this way. Collection of like terms. I have 2x, which is this. This is minus 3 crossover become plus 3x is equals to, this is my plus 3 crossover to this I become minus 3. Now this is 5x is equals to minus 3. Divide both sides by 5. Cancel. X is equals to minus 3 over 5. So that is our x. Now let us proceed. Let's take another question, the 8th question now. The 8th question says 4 raised to the power x minus 16 is equal to 0. 8. 4 raised to the power x minus 16 is equals to 0. Okay, let me be sure. 4 raised to the power x minus 16 equals to 0. Okay, from here, we take this guy out. It doesn't have x, so it's like collecting like terms. So we have 4 raised to the power x is equals to 16. And they have something in common, 4 exists here. So I have 4 raised to the power x is equals to 4 raised to the power 2, which will give me 16. So I have common base, cancel, my x is equals to 2. Ninth question. Sixteen raised to the power 3 minus x. 16 raised to the power 3 minus x. 3 minus x is equals to 1. 16 raised to the power 3 minus x is equals to 1. Okay? If this is what it is. Now, this 1, there is no way we can equate it having the same base with this. But we know that any number raised to the power 0 is equals to 1 according to the 0 index law, which means I can turn this one into 16 and I'll have 16 raised to the power 0. Which I know 16 raised to the power 0 is equivalent to 1. So that I'll have common basis. From there I can proceed further. Otherwise there's nothing that can be done here. So with that knowledge I now have 16 raised to the power 3 minus x is equals to 16 raised to the power 0 because 16 raised to the power 0 is 1. Now if this is true, I have the same base. I can now cancel this. 3 minus x is equals to 0. Collection of like terms, minus x is equals to, this crossover become minus 3. The Bible says by minus, this cancel, my x is equals to 3. Because this will go. So that is it. Let us, now, how do you know you're correct? For example, let us just check. Okay, we say in every equation the left hand side must equal the right hand side. If x is 3, I put my 3 here. 3 minus 3 is 0. 16 raised to the power 0 is 1. So here is 1, here is 1. So by that you know you're correct.